Welcome to the Binding Chemistry, and today's topic is modern periodic law. It was shown by Henry Moseley in 1913 that atomic number and not the atomic weight is the fundamental property of the atom. Thus, the periodic law was modified as the properties of the elements are the periodic function of their atomic number. Now, removal of drawbacks of Mendeleef's periodic table. Some of the defects present in the periodic classification have been removed, which are discussed as first, position of hydrogen. Dual behavior of hydrogen is explained by the fact that it has one electron in its orbit. When it loses one electron, it gives SO plus ions and behaves like alkali metals. And when it gains one electron, it gives H sub minus ion and behaves like halogens. The dual behavior of hydrogen is due to this peculiar electronic arrangement. Position of isotopes. There were no place for isotopes of the same element. Since the isotopes of the same element possess the same atomic number, they must occupy one place in the periodic table. Third one, anomalous pairs. Certain elements of higher atomic weight were placed before those having less value. Like, for example, Ar atomic at 39.9 is placed in 0 group, but K atomic weight 339.1 placed in first group. And similarly, CO atomic weight 58.9 and nickel 58.7 placed in 8th group, while T atomic weight 127.6 and I 127.0 are placed in 7th group. But it has been found that elements having higher atomic weight possess lower atomic number and consequently must occupy their desired position in the periodic table. Fourth, position of 8 group elements. In long periods, 18 elements are to be distributed among 8 groups. Groups 1 to 7 get 2 elements each, and 0 groups contains only inactive element. The rest of the 3 elements are placed at one place in a new group, known as 8 groups. This lack of a space justifies the inclusion of this group in the periodic table. Fifth, position of rare earths element. Since rare earth elements have same chemical properties, hence they are placed in 3b of periodic table. Sixth, position of transuranic elements. The number of valency electrons in the case of all these elements remains the same, although atomic number increases. Since they possess the same number of valency electrons, their chemical behavior is also similar. This justifies their position in the periodic table.